Okay. If you think about it, we basically have one big notation introduced. This one can mean a lot. Number one, it can mean Riemann sum, which means I have a lot of small triangles, rectangles. And I push it to the limit. Every rectangle become a line almost. I sum them all together. I have infinite many, so I cannot do sum anymore. I do integration. Second, this one is related to the net area below a function. Number three, of course, this one is related to antiderivatives. That will be the majority of the time when we use integration, we do antiderivatives. Moreover, we try something called U sub. All right. Now, what we will do is we will go to chapter 6. If you recall, we introduced the derivative. After that, we did the application of derivative. We talk about how to find the maximum, minimum, the optimization. We talk about L'Hopital's rule. Now, when we finished integration, of course, we want the application of integral. What can you use integral for? All right. So let's talk about the first one. Of course, we use it to find the area, but this time not below, but between curves. The idea is quite easy. Back in ancient Greek, they know how to do triangles, how to do rectangles, and we know how to do circles or even ellipse or some weird shape. But now if you think about it, can you do a area like this? What is that thing? Well, that is the area enclosed by two curves. The first curve is going to be a parabola, which is on the top. Okay. The second one is going to be a straight line. You were never taught a formula of how to find the area of a parabola. Meanwhile, parabola is probably the easiest curve you can see. So you should be able to do it. Sounds good? So instead of introducing you more formulas for like one formula for parabola, one formula for cube, one formula for others, let's just stop everything. Just say, hey, we have one way to solve them all. That is by integration. Okay. How do you do that? Exactly the same idea. You have the area, right? Okay. What I'm going to do is I'm going to cut you into small pieces. Good so far? Each one is going to be something like this. And like that. This comes from the one on the top. This one comes from the one on the bottom. Okay. Still, we're going to say when you let n goes to infinity, this is roughly like a rectangle. Still okay? So you still have a width and height. Okay. What's your width? Width is delta x. What's your height? Before, your height is f. Why? Because this is 0. Right? That's the top minus the bottom. Now this is not 0 anymore. This may be g. But nonetheless, the height is going to be f minus g. Make sense to everybody? Okay, so we still have rectangles, but this time the rectangle does not go from 0 all the way to the function. It actually goes from one function to the other function. Okay, and what you should do is you should use the higher function to minus the lower function to get how long that thing is. That will be the height of the rectangle. This will be the width. This will be the sum. And then finally, you let n goes to infinity. Can you see this one becomes, sum become this. Delta x become dx. And the one in the middle become fx minus gx. Sounds good? Let me write it down. Number 1, area between curves. Assume that following two things. Number 1, f and the g are two curves. And they're both continuous. On the interval AB. So you can take the integral, right? If it's continuous, you can take the integral. Second, fx is bigger than or equal than gx on AB, which means we do have one above, one below. Something like that. Then what we can say is that the area between f and g is given by a equals the integration from the interval, the top minus the bottom. That will be the formula. This will be the area we're looking for. Sounds good? Okay. You may start to wonder, what if the area is negative? Right? You still use this one minus this one, but remember, you're going to minus something which is negative, so that's still going to be this height. So you don't have to actually vary by cases. Even if it's negative, just minus. Okay, let's try some examples. Let's try easy one first. Find the area bounded by y equals x, y equals 4 minus x equals 0, x equals 1. All right. A little bit bigger. Okay. 1, 2, 3, 4. Y equals 4 minus x. Y equals x. You may wonder where this is. This happens at 2. So y is actually here. Then the area we're looking for will be this part. Sounds good? What's the shape? It's a trapezoid. Do you know the formula? Technically, in geometry, you can do it. This is 4. Spend some time, you will figure out this is 2. The height is 1, so it's 4 plus 2 times 1 divided by 2. The answer is going to be 3. Okay? It will take you some time to figure out everything in geometry. But now, let's say, forget about it. Let's just take the integral. From where to where? Who is above? Who is below? So f minus g from 0 to 1, that will be the area. What does it represent? It represents the sum of all these small rectangles if you cut them by little pieces. Okay? Now, the rest is just try to find this. Super easy. Plug in 1. Plug in 0. Which give you 3. Sounds good? So you can forget about the geometry now. If you know the curve, both curve, you can just do the integration. That's nice. Let's try something else. Find the area enclosed by y equals x squared and y equals 2 minus x squared. Again, the first job, try to draw something. x squared. Then this is y equals negative x squared. Okay, exactly symmetric. Now you need y equals 2 minus x squared, which is minus x squared moved up by 2. So take the whole thing, shift it up by 2, and that will be the area you're looking for. What's the shape? Well, it's almost like a football, right? It's not a circle. It's not anything you have known before, but for now you don't have to. Integration. Who is on the top? Who is on the bottom? That's good. From where to where? These two numbers. From here to here. Right? Moreover, it's symmetric. So one is a number, the other one is exactly the opposite of that number. How do you know where these numbers are? That's where these two intersect, right? Knowing two curves, can you know where they intersect? You just put them together and solve it together. Okay, so that's how we're going to do it. Even though we don't have the ending point given us, actually we can find it by ourselves. So let this one and this one happen together, which means which point will satisfy both. That means which point is the intersection of these two things. Solve it. That gives you y equals x squared. So x squared equals 2 minus x squared. Something is wrong. Oh, no, it's not wrong. It's right. And according to what we see, this is negative 1. This is 1. It's not given. It's found by ourselves. But once we have that, the rest will be easy. Nope. 2/3 times negative 1 cube. 4, 12, 8 over 3. Okay. It's a lot of work, but seriously, everything below this one is old. Only the first part is new. That is the top minus the bottom and the final ending point. All right. Is the idea clear? So now I can actually give you any curve. I can give you something like this. Okay, I'm gonna give you something like that. Whatever. As long as you know the formula for both curve, you know then it's nothing but integrate from here to here, and then the top minus the bottom, do the integration. Okay, that's the idea. Now let's take another example. Okay, find the area between, or let's say bounded by, let's not say bounded by, I would say between. Sin x and cosine x on the interval 0 to pi over 2. sine pi over 2. Okay? To remember how to draw cosine, take the whole thing, shift to the left, you start from here. That's cosine. So what's the area are we looking for? We're looking for between them, so this and this, all the way to pi over 2. So it's like a butterfly shape. All right. Can you set it up? Who's above both function? You have sine and cosine. Who is above the other one? Can you see it depends? Right? The first part, red is above the black, so cosine is bigger than sine. Okay. However, for the second part, the black is above the red, so sine is bigger than cosine. Okay. So how are you going to deal with it? You just cut it in the middle, do the integration on the left, and do the integration on the right, and then finally you just sum them together. Make sense here? Okay, so that's how you're going to do it. You just take the sum. So, like we said before, in order to use the formula, you need to make sure one is above the other one. Okay, but what if sometimes this one is above, sometimes this one is above? That means you don't have one which is above the other one all the time. Good so far? And now you can see an easy solution is just take here on the left, I take black minus red. On the right, I take red minus black. So you can keep intersecting each other. Okay, whatever you like. I just cut you into each pieces, and I make sure that on each piece, I know one is firmly bigger than the other. Okay, so that's how we do it. We split them into multiple pieces. Good. Now we just need the starting and ending point. The first part certainly starts from 0. The last one certainly ends at pi over 2. The number we're missing here and here, they're clearly the same. Where the first one stops is where the second one starts. And that number is here. Sounds good? What is that number? That's where sine and the cosine are the same from 0 to 90 degree. What is that? 45 degree. Sounds good? Usually you need to set them up and try to solve it. Of course you can do it, but for this case, well, we know the fact. It's pi over 4. All right. I will skip the rest. The answer is going to be this. Take it as a practice. And you can practice by yourself. Like I said, there's nothing new starting from this point. It's purely just finding the antiderivative, plugging ending points. Sounds good? It's number 3. Let's try a harder one. Find the area enclosed by y equals x minus 2 and x equals y squared. This is easy. It's a line. Does everybody know how to draw this? Do you know how to draw this? What about this? Should make sense, right? It should be basically similar like that, but rotated by 90 degrees because you're doing things in X instead of Y. Moreover, it should point to the positive direction of X. So more like that. Okay. The area I'm looking for will be in between. All right. Clearly, to do that, I need to know where these 2 points are. Right? That's where I start my and I split. So first, set them to be together. And go ahead and try to solve for X and Y. You should have 2 answers, each one corresponding to 1 point. Okay. Starting from the first one, how to say X equals Y squared. So Y equals okay. Now because X equals Y squared, that implies if Y is 2, X should be 4. And if Y is -1, X should be 1. So this is 4, 2. This is 1, -1. Sounds good? Okay, we have the 2 points. Now how do we set up the integral? Which one is above which one? Can you see that? We should split them here because we have 2 different cases on each part. On the right, the parabola is above the line, right? On the left, the parabola is above the parabola. Still okay? So it should have 2 parts. Okay, let me write it down. First part from here to here, parabola above the parabola. Second part from 1 to 4. That's clearly the parabola above the line. Good. Now what's special about this parabola? Remember, we want to put fx here, right? But what we have is not a function of x. To do that, we actually have to do additional term, which is this. Sounds good? Okay, the positive one gave you this. The negative one gave you this. That's why you have 2 pieces of parabolas together. Okay? With that in mind, what we can do is, on the first part, it's the top minus the bottom. Okay? The second part, it's going to be the top minus the bottom. Because you need a function of x, you cannot start with this. You have to actually solve y from here. Oh, shit. Change the color. So far, so good. Now change the color. That's where they intersect. Does everything make sense here? Okay. Again, I skipped the computation. It should be 9/2. Skipped. Do it by yourself. The harder part is try to set this up. All right. Does everything here make sense? Why we split them into two parts? Okay, which is on which, on top of which, and how do we actually start from a function of y and transfer it into a function of x? Then you have two pieces. We have to do that. Okay. Number one, that's great. We did it. Number two, that's not the best way. Why? Because it looks way more complicated than it should be. Think about this. It's difficult because you have two parts. But really, if you think about it, if you just turn your head by 90 degrees, you rotate the whole thing. What you should have is something like this, right? Okay. If you look at everything from this perspective, what happened? Number one, I don't have two parts. It's always the straight line is above the parabola. Second, it's always from here to here. So I can, instead of doing two integrals, I only need to do one integral. Okay. Second, if before I need to see x equal to y squared, I have to change this to be y equals plus or minus square root of x. This time I don't have to. I can just start from this one. Because you switched the x and y. So your x is basically your y now. Make sense so far? Okay. So if you could just be a little bit clever by switching the whole thing, by rotating it for 90 degrees, you figure this is way easier than it should be. Okay, than what we just did. Of course, to do that, you need to rethink about what you do. Okay? Just be careful. How do you do this one this time? I just do the integral. Fine. What do? You cut them into pieces. Then you have rectangles, right? Okay, this rectangle comes from the line. This bottom comes from the parabola. Now, what about this rectangle? Well, if you think about it, before the width was delta x. But remember, this time your x is here, your y is here. So if you really think about your width now should be delta y. Make sense so far? Okay, what's the height? The height should be this one minus that one, but what is that one? That is going to be a function of y, of the straight line. And this one should be a function of y in terms of the parabola. Good so far? All right, with that in mind, now let's redo this. Of course, we don't want to too much. Let's erase this. We don't really want to actually switch everything, so let me just copy everything. Or let's just redraw. Okay, this is what we have. 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 Okay, 1, negative 1, 4, 2. Okay. Before we do everything, why? Because we cut everything to this point. We want to sum all these rectangles together. That's why we do dx. Okay, that's why we need to use the top minus the bottom. That's why we need to split and all the crap we have to do. Okay, good. This time, simply just change the way you cut the thing. Instead of cutting everything like that, you cut everything this way. Okay, now what do you have? You have a piece like that, which you wish will be something like a rectangle. Okay, what's the width? That's going to be delta y. And if you take the integral, it's going to be dy. Good so far? What should you put here for the height of the rectangle? That's got to be the one on the right minus the one on the left. Remember, for x, we take the one above minus the one below, right? This one we take the one on the right minus the one on the left. Why? Because going to the right is the positive direction. Finally, from where to where? Well, 1, -1, 4, 2. Before, when we integrate, we focus on 0, we focus on 1, we focus on 4, which is the x value, right? This time we're actually doing things in this way. So what we should focus on will be this one and this one here. Good so far? And from here, you can see this is a nice formula. Why? Because the straight line is always to the right of the parabola. So you don't even have to have two parts. Is everything clear? All right, that's how we are going to do it. Of course. The one on the right, the one on the left, we know the one on the right is a straight line. The one on the left is going to be the, let me see this, right minus left. Okay, the one on the right is going to be a straight line. The one on the left is going to be this. Moreover, if you want to take some integration with respect to dy, do you feel like you should put a function of y there? Right? When we do u sub, you cannot have a du and then you have x there. Or you cannot have a u there and then you are doing dx. It's not going to be doable. So you better write everything, which is fine. Also, you want to write them in terms of a function of y. So don't use this, but use this instead. It's the same line, right? It's the same line, but this is the function of y. So that's the right. And this is already a function of y. So sounds good. Okay. Now from here, you can see this one is way easier than the one we just wrote down, which has two parts, plus you have square root to handle. This one is really quick. You already have it. It's going to be 1/2 y squared plus 2y, which gives am I right? 1 plus 2. 1 plus 2. Mm-hmm. 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 So I have 1. That's 1/2 plus 10. That's minus 1/3. Okay. Minus. Plus. Yes, that's right. Which is, I guess it's right, which is 4 minus 2/3, which is 12/3. No, 10/3. So I gave you the wrong answer here. Should be 10/3. Okay. And you can try. When you finish this class, try this and try the one we just did. You will find this one's super long and this one's super quick. Okay.
Aren't we integrating from 2 to -1?
I guess that's why. -1 to 2. So maybe that's right. Let's see. We have 1/2 times 4 plus 4 minus 8/3. Let's do it again. 6. Hold on. 6. 18, 10/3 plus 3/2 minus 1/3. That's 3 plus. Okay, so I was right. Take it back. All right. Sounds good? That's the second thing we want to talk about. When you have an area, of course you can do this. Above minus below, if you want to do dx. Okay? Or you can go from C to D, dy, where you use the right to minus the left. Both method works. The first one is based on the fact of cutting everything in this and sum all the rectangles together. The second one is based on the fact you still have the same shape. Okay. But this time you cut them horizontally and sum all these rectangles together. Sometimes one way is easier than the other. Okay, like the example we just showed. Okay. Moreover, one principle. If you are taking dx, you need to make sure everything here will be a function of x. If it's a function of y, you cannot do it. That's why even though you see x equals y squared, you have to change it to be y equal to square root of x. Okay. Similarly, to do the one on the bottom, you need to make sure that everything is in term of y. Otherwise you cannot do it. Sound good? All right. The last example, you do it by yourself. Find the area between y equals square root of x, y equals x squared and y equals x. Moreover, do it in both ways. Which means do it in dx and do it in dy. Don't actually go ahead and try to find the number. Just try to set it up. Okay, the key is how to set it up. The integration is relatively easy. Above minus below, so the straight line minus the parabola. Okay. Right minus left, so the parabola minus the straight line. But you need to change it to be in function of y. So y equals x actually gives you x equal to y. Y equals x squared give you x equal to square root of y. Okay, so you should use this minus that. Sounds good? More practice will come in the textbook and your web works. For this part, the most challenging thing is actually try to set it up. So in the final exam, I'm going to test you guys on this. I will not ask you to finish the whole area. I will just say set it up. Okay, which means you need to set everything up to the here. But how to do the integral really is not our concern, because that go back to chapter 5. Okay. Something for you to think about. Do you know the formula of a circle? The area of the circle? Pi r square, right? Why? Your teacher told you so, right? Okay. Now, actually, you have the tool. Do you know the formula of a circle? Right. Do you know how to find the area? No, negative r. Of a circle using integral, that's going to be from negative r to r. Right? Square root of r squared minus x squared, that's your y. Dx, and that will give you the area. And then you times by 2. Sounds good? If you go ahead and try to do the integral, this one should be pi r squared. Okay? I want to challenge you to think about how to do the integral of this. Okay. Of course, you can try either one when r equals 1. Okay, when you finish, this answer should be pi. Pi over 2, actually, it's half the circle. Okay, think about it. How to do the integral of this. And once you know how to do that, you know the formula of a circle. This time, purely by yourself. You don't take it for granted. All right, that will be all we have for today.